And if this is on, yeah, it is on. Well, good evening. Again, welcome here to Kopernik Observatory. We'd like to thank you all for those that came here in person. I want to also wish a good evening to you on the live stream. My name is Drew Desker. I'm the director here at Kopernik, and really looking forward to tonight's presentation. Just for those of you who are on the live stream, we'll give you a little audience pan so you can see who all's here tonight. Unfortunately, here at Broome County, we've developed, we're now at a high community COVID spread, so we are requiring people inside to wear a mask, and but hopefully we can get beyond that soon. Tonight's program is actually one that I try to have basically every year. How long has this program been around, Drew? About 10, yeah, okay, 10 years. So this is a robotics club that has been of high school students that have been around for 10 years. I'm sure Drew, you guys will talk a little bit more about that. And in fact, I remember when Drew was actually one of the students in it, and now he works at Lockheed Martin as an engineer and has taken over as a mentor. And it's great sort of to have that continuity. But anyway, I just when you see what this thing can do, and to know that these are students that just, some of them don't even have their license yet. Right?
I have it.
Well, I said some. I said some. But anyway, it's really a testament to the hard work that they put in, and the mentors that they work with, and the people that support them, and the corporations that support them to make this happen. And ultimately, these people could ultimately turn into the people that build that Perseverance rover. We now have a nice Perseverance sort of a selfie wall back there, and we have that on loan. We have also a Perseverance model in the back display case on loan from the Jet Propulsion Laboratory. So check that out as well. So again, maybe in a couple of years, you guys could be out in California working at JPL. But let's dive into this actual program. So who's gonna start this out?
I'll start first.
All right. Well, this is Drew Williams, and he's the chief mentor of the Southern Tier Robotics Club.
Yep.
Hi, I just want to say my name again is Drew Williams. I work at Lockheed Martin as a software engineer. I graduated from the University at Buffalo in 2020 and graduated Vestal High School in 2016. I've been a part of this club since I was a freshman in high school. We went under a different name when we were based out of Union Endicott, so it was previously called Tigertronics, but now that we're located in Vestal and are trying to get more teams and schools from the surrounding area involved, we thought it'd be good to rebrand as more of a broad Southern Tier Robotics with a cool new logo. And we're here to basically talk about what kind of a club we are, what program we're present in, which is called First Robotics, and then we're going to show off our robot that competed in Pittsburgh around a month ago now. So just want to do that, give a quick introduction, and then our students will also give a quick intro.
Okay, I'm Andy. I'm the oldest person on the team right now. I'm a senior at Vestal High School, and this is technically my second year on the team. I've been to 2 competitions, and it's a great experience.
I'm Jalen. I'm a sophomore, and this is my first year of robotics.
My name's Aiden. I'm a freshman, and obviously my first year because I'm a freshman.
All right.
What is Southern Tier Robotics? We are a competitive robotics team from Vestal and Union Endicott. We're kind of similar to an esports team, but not really. We teach students about science, technology, engineering, math, and more. And that's a photo from 2019 from the Pittsburgh Regional. What is FIRST in FRC? FIRST is a nonprofit organization focused on inspiring young people to be technology leaders and innovators. FIRST is a program for high schoolers where they are challenged to build a 120-pound robot in 6 weeks to play in a game that changes every year. This year, the game was Rapid React, and we had to shoot basically giant tennis balls into a big hoop. And we had to climb in kind of like a monkey bar system. This is a photo of the team in the pit. At competition, each team has their own pit where they sit and they fix the robot after I go break it every match. That's the photo of the team from this year. These are 2 photos of the robot from previous years. So this is the climbing system that I was talking about. As you can see, there are 2 bars here. You can reach up and climb to 2 of these bars just regularly, but these 2 bars you have to climb from the middle bar. That's us right there. We were able to climb to the mid-rung this year. We had to take the climber off to fit it in the car, but that's that. You can see some photos from our competition. The competition is the prime time of FRC. All the teams from the area gather in the same location for a multiple day competition. There is one practice day where you're queued up for practice matches just to make sure that everything runs smoothly. And then the next 2 days are qualification matches. And then the final day is the playoffs. In between matches, teams will go back to their pit and improve their robots, and they can also go into a little area and test their robots. At the end, the teams with the most points initiated in the form of snake drafts, where they pick teams for the finals of the competition.
Right here we have a video of one of the matches that we were in as a team. I think if I start the video. Yeah, so I'll pause it right at the start. I don't remember what match this is. Okay, yeah. So if you can see the mouse, we're in the middle on the red alliance side. So each match in the qualification matches is a 3v3 between randomly picked teams. So you actually work with the teams on your on the red alliance if you're on red, and vice versa. So you can plan and strategize before each match and figure out, if, let's say, 3201 is really good at putting balls in the low goal, that's what they're going to focus on, and so on. So I think in this match, we had a bunch of basically issues during competition, which we had to resolve at competition, which is pretty stressful for the team, but also really fun and a good learning experience. So the first 15 seconds is actually fully autonomous, where robots basically using cameras and sensors on the robot to detect where it is in the field. You were supposed to shoot your color ball into this upper hoop up here or into the lower hoop down here. And the points in autonomous were worth double the amount that were basically awarded in the rest of the match. So it was pretty valuable to have an autonomous routine.
16-8, early lead.
So you can see our robot trying to grab a ball here, and then shoot a ball in. We miss, but we end up basically tuning our shot during the match, as we had issues with our robot where we weren't able to basically get the right shot speed sometimes, and the right arc, because you can see a big problem this year, which we didn't realize until competition, was that the shape of the upper hoop causes a lot of balls to bounce out if they're shot at like a not optimal arc. So that was the biggest issue we were trying to solve during competition. But I'd say our robot was one of the best at the competition at picking up balls off the floor, as well as doing the mid-rung climb, which was pretty fast for us. And then I think we also played a little bit of defense in some matches. I don't think it's in this match though, but yeah, so basically you want to score as many balls into the goal as possible in your 2 minutes and 30 seconds of match time. So our strategy was basically pick up 2 balls, go grab 2 more, or pick up 2 balls, shoot them, go grab 2 more, and keep going. So Andy here was the main driver of the robot, so she controlled all of the, basically where the robot was going, and then Aiden over here controlled the rest of the robot, so the climber, the intaking, and the shooting. A lot of that stuff was automated though, using computer vision and different sensors to automatically detect where to point the turret on our robot and what speed to shoot at. So you can see us hanging on the low bar there. That was our strategy that game. And then our 2 partners on the mid rung, we ended up getting a ranking point, which is basically how the teams are ranked during the competition. So if you win, you get 2 ranking points, and if you do extra stuff during the competition, like have a certain amount of balls scored or a certain amount of climb points, you get the ranking point. So that's about it for that video. Any questions? I know it's probably a complicated thing to look at, but we can do a quick a demo of our robot, show it off, and yeah. So do you guys want to get that set up?
Yeah.
Yeah.
If you could repeat it for the live stream.
Yep.
How did you test? Did you have to make your own test setup for the basket that you'd be shooting into? How'd you do that?
Yeah. So the question was, when we were building our robot, how did we kind of assemble the practice area, and how did we get a good feel for what the goal would be like at competition? So basically, during the first week of competition, we tried to build as many of the field elements as possible, as close as as we can to the competition versions. However, this year one of our biggest challenges wasn't really technical at all, but more of a people problem where we actually Andy was the only one on the team for the first 2 weeks. We had a tough time getting students, so we ended up building basically a hoop that was the diameter and height, and then had the vision target on it, but not really. We didn't really have the sloping parts inward, which were pretty important. We learned, so yeah. Ideally, we would have built the full version, but it also requires a lot of wood and pricey materials. Yeah.
When you build your robot, is it a kit that you get and you assemble it?
Um,
Or does every team start from scratch and
Yeah.
design it for each?
The question was, does the robot come in like a kit and you build it from there, or is it from scratch?
So the answer to that question is kind of yes or no. Some teams can get a kit and like build a robot from the parts that they get, and it will usually be like a really basic like tank robot. They might not even have like a shooter or a climber. But teams that have been around a little bit longer and maybe have a little bit more funding can build a robot like that from completely scratch.
Yeah, so to add on to that, what Andy was talking about is you can get a kit of parts drivetrain that you can opt into, and that basically gets your robot moving on the ground. However, we decided not to go with that as we were experienced enough to do it ourselves and do the CAD. So all of the parts on the robot were CAD'd in a computer design program, Inventor, and then we either machined the parts by hand or we had a laser cutter sponsor cut basically all of the flat metal parts on the robot. So the shooter, the turret, the belly pan, the intake, but everything that isn't flat metal was made in the Vestal High School. But yeah, everything was designed from scratch, basically. Yep. Yeah.
Do you recycle any parts from year to year with the robot?
So the question was, do we recycle parts year to year? The question, or the answer to that is, it's against the rules to reuse parts that were manufactured during previous years. So, for example, we couldn't use the laser cut parts, but any parts that are COTS, commercial off the shelf, so like the basically stuff you just buy, so like the motors or the wheels and the belts and stuff, you can reuse. And you're allowed to reuse designs, but the trick is you have to publish them publicly before the start of the next season. And that includes code too. So each year we publish our code so we're able to reuse it next year.
What language do you use for the software? Is it C or C++?
Yeah, so the question was, what programming language do we use? We use C++, 17, so pretty modern version of C++. The computer on the robot is a Linux computer, so that does all the computation and tells the motors, controllers what to do, and then that gets sent over a Wi-Fi router to the laptop, which at competition has controllers plugged into it, which basically feed commands from the joystick to the computer on the robot.
What do you use for a computer?
It's so the question was, what do we use for a computer? It's called a Robo-Rio, but it's basically like a Raspberry Pi or a Linux computer, so it's an ARM processor.
You just have one?
Yeah, so the question was if there's just one, and the answer is basically that kind of yes, the main computer is that Robo-Rio, but technically some of the motor controllers have built-in microprocessors on them that do fancy control algorithm stuff like PID commands and that kind of thing, PID control. But yeah, mainly the Robo-Rio does the processing.
That's another question. What are you using for mobility? As far as I remember, in the past, you would use mechanism wheels, and
Yeah.
so maybe you could talk about. Are you still using that, or did you switch to a different technology?
Yeah, so the question was, in the past we had used mechanism wheels or what we call a swerve drive in the past, which is basically 4 regular wheels that rotate independently that allow you to move basically with 3 degrees of freedom. So you can strafe side to side and rotate at the same time. You want to talk about that?
This year we have sort of like what you would normally call a tank drive, and it's kind of like mechanism, but you can only drive in one direction, and to turn you have to like either stop moving or you can only stop moving one wheels. So it's probably the easiest out of the drivetrains to make, but it's not like the most mobile.
Yeah, so one of the reasons we went tank drive this year was because at the start of build season we only had one person, and when we moved schools we didn't have basically any machining equipment that was necessary to build these other types of more complex drivetrains. So ideally we would have liked to make a swerve drive, but which ended up actually being really kind of necessary this year for game strategy wise, but yeah, we didn't have the machining capability, and rather than stretch ourselves on getting just a driving robot, we rather focus on making great, basically better game piece manipulators and mechanisms. Because without a CNC miller lathe, we can't really make anything too complex without having to ask for outside help, which takes longer.
When do you get your requirements for the competition?
Yeah, so the question was, when do we get the requirements for competition? So in the first Saturday of January is when the game is revealed with a reveal video that's like an animation that's released by First. And that basically gives you an overview of the game, and then they release the manual. And then you have 6 weeks to go from that to that. And so we meet. It's a lot of long hours. First week is usually going over the rules and strategy and building the drive base. And then after that is working on the game manipulation part of the robot. So yeah, 6 weeks is a pretty short time frame, shorter than most real engineering projects by far. But it's a real challenge to get done, and I think that's what makes it fun, because with such a short time crunch, it's, I don't know, you just get put under pressure more, and it's more fun to me that way. Yeah.
So are you the guy that teaches the students how to do the C++ programming? Because the schools aren't going to do that.
Yeah, so the question was, am I the person that teaches the programming, which is yes. The high schools do have AP computer science and programming classes, so they do learn C++, but not to the level necessary to program a robot like this. So what we want to, basically the mentor's job is different for every team. Some mentors are a lot more involved, some mentors aren't involved that much. It's not really regulated like other programs. So I guess my philosophy to mentoring is that the mentors can help basically as much as possible if the kids want it. So for example, like this year there weren't really a lot of programming students, so I ended up doing a lot of the coding, but I really want to get more kids involved next year and hopefully get more programming students to learn about the robot and do stuff in the off season, so from now until next January. We also have 2 other mentors that another one works at Lockheed Martin, and he's the kind of CAD and mechanical mentor. And then another person is the machinist mentor who helps the kids actually build the robot. I will say the kids basically built the whole robot this year with our help. because Andy was the only one. She also helped a lot because she was the only senior on the team that knew how to basically do anything with robots. So she was also really helpful in, teaching other kids. And I want to get more kids involved as well. So hopefully we can have like an infinite loop of kids training the younger ones, instead of the mentors having to do everything.
We have a couple of questions that came in through the live stream. Holly asks, what does your team do besides build the competition robot?
Yeah, so we do outreach events like these, trying to, spread awareness about our program. We also do, volunteer events. So we went to, I think, the Union Endicott High School, or middle school and elementary school a couple years ago, and showed off our robot there. We've also been to a couple of local, like festivals and events through the past couple of years, showing off the robot and doing like different demos and, science stuff like that. More outreach is always good though, so maybe we can plan something.
Unless you had any other thing you wanted to add to that, okay. Another question. This is one of my favorite people who are on our live stream. Their tag is only in Antarctica, and is a frequent contributor to our YouTube stream. And he tells me he's not in Antarctica. But anyway, their question is, what do the winners win as a prize from the competition?
So the winners get the pride and joy of going to the World Championships and spending $5,000 more to go to championships in Houston. So, yeah, you don't win anything like monetary wise. You get a blue banner and a trophy and like a medal. There's different awards at the competition though. It's not just about, building the robot that wins the competition. There's different awards for like, a control systems award for your software. And then there's also non-technical awards like the Chairman's Award, which is technically a higher tier award than winning. It's about, sending the message of first throughout, your community and doing things like that. All
right, so actually that first person, Holly, wanted to say hi from your Pittsburgh game announcer. Oh. So the woman who was the Pittsburgh game announcer is actually watching you guys. So wave to Holly. There you go. Trying to think here. And do we have any other questions in-house here? Or should we let them do a demo? Yeah. Let's do a demo. All right.
Can I move the camera?
Oh, yeah, absolutely.
Oh, it's already in. Do we have to keep the Ethernet in, or? Yeah. All right.
Too much.
Okay, since after building everything that you learned, is there anything you would do different if you had to do it over again?
So the question is, after having built it and gone through the competition, now that you know what you know, what would you have done different with this particular robot?
Andy, do you want to answer?
Yeah, so honestly, there's a lot I wish we'd done differently. I wish we had focused a little bit more on building the game pieces and getting more practice in this year. And I kind of wish we ditched climbing in general and just focused more on shooting. But I think the important part about competition, isn't just competing and winning. It's also learning from your mistakes and improving when you go next year.
Yeah, and just to add on to that, more specifically, I guess, to help with our issues with shooting the ball and the backspin causing a weird arc, we probably would have wanted to do a different shooter design where our adjustable hood, which ended up breaking during competition, so we bolted it together. So we probably would have wanted another set of wheels in the back to prevent backspin from happening on the balls, which would have given it a better arc. Yeah, you want to shoot a couple balls. So
That's because I'm not shooting
yeah,
control.
so we have a demo vision target here that simulates basically what the robot would see on the field. So if you can align it to a goal, you can see basically the turret automatically moves to the target's angle depending on where the goal is relative to the robot. And then it would shoot it. So yeah. Right now I have it on a low power mode just because I don't want it flying through the ceiling.
Thank you.
Yeah.
Hold up, let me. Get the.
Yeah, our turret was probably our best feature. We were basically able to align anywhere on the field perfectly with the goal and pick up basically straight up to the goal. So we can also show off the intake. So that intake basically, it works better with the robot bumpers on, which we don't have here today, but it basically picks up the balls off the ground with those spinning wheels and also extends forward with pneumatics, which is like compressed air. So that was that sound that was going off earlier, was the compressor running. You want to just spit out more balls, I guess. And then I guess another feature we can show off is just drive it slowly around. Andy, do you know how to change the joystick? Here, I'll help you. So
You all signed a waiver before you came in here.
yeah, just enable it when you're ready. So yeah, one of the big things obviously is mobility on the field. So we have kind of a standard drivetrain this year where it basically just moves like a tank. So, you know, forward, backward, side to side. Yeah. And these robots, I think this robot's max speed is around 17 feet per second on a full battery. And they're powered by 12-volt lead-acid batteries, kind of like what's in a car or motorcycle. And we run them dry basically in 2 minutes flat. So each match is 2 minutes, 30 seconds, and they're basically dead by the end. So unfortunately, during our last match, we accidentally put in a dead battery, and that caused us to not work very well in our last match, but it happens.
What'd you do if I
Yeah,
just spin it around
also,
at full speed?
like
What would you do if I
Andy
just
said
spun it around
earlier,
at full
our
speed?
climber arms aren't attached right now. They were attached right here on this bar to this pivoting roller up here, which would raise and lower the arms of the robot with basically a tight rope. Yeah, so the question was any parts 3D printed, and there's actually a lot of parts on the robot that are 3D printed. All of these, basically anything that's crazy colors. So the spacers, a lot of spacers are 3D printed. These wheels, yeah, basically. So during the competition, the radio is configured to only connect to a certain Wi-Fi network. So you can only connect to it over USB, but we just haven't gotten the chance to reconfigure it to be wireless again. So I guess another thing to bring up is that you can, like I said before, there's a lot of defense that goes on during competition, so you have to build your robot robustly. And like our intake that sticks out of the robot is basically completely bent, but still works functionally. And you basically have to build your robot to withstand full-speed other robot impacts, which are pretty deadly. And then also, you know, falling off the top bar, which is around 3 feet in the air. And Our robot this year actually didn't really have any too big of mechanical, problems from breaking. Besides the climber arm falling off.
Okay, that was like literally 2 screws came off, so it was
Yeah.
fine.
But all the 3D printed parts held up well. They're printed at a high infill percentage, so they're pretty sturdy. If you want, Andy, can you disable the robot? You guys can get up close if you want. The robot is disabled, so it won't do anything.
I won't do anything.
Promise?
Yep.
Yep.
Yeah. And if you have any more questions, feel free to ask.
Sorry.
Now, how did you build, how did you get all the parts to work?
So the question was, how do you get all the parts to work? So I guess from a general perspective, our kind of design philosophy is to do as much as you can in on the computer first. So designing your parts in Inventor and making sure everything fits together that way. And then hopefully, there's always something that goes wrong though, no matter what. No matter how much time you put into it, there's always going to be something that's wrong. So when you're building and assembling your robot, you figure these things out and, make changes on the fly if needed. So one example of that was our biggest problem during the during the practice day of competition was with our climber. We didn't get to put our climber on until the competition because we didn't get it done until then. And we just hoped it would work and follow all the rules, and it ended up being overweight by 5 pounds. So we ended up having to our original climber was hopefully going to be able to climb to that top bar, but we had to get it under the weight, we had to transition it to make it only go to the mid rung and take off a couple of parts and drill a bunch of holes in the robot. Which, if everything was perfect, the weight of the robot would have been in CAD, but not everything is accounted for, like the wires or stuff like that. So 125 pounds. I think we were around 124.9 at the end. Yeah, just skirted under the weight limit there.
Just see if they got any other questions.
Yep.
On the live stream.
No. Yeah.
You said you guys started from scratch, so how did you even start coming up with ideas?
Yeah, so maybe Andy can talk a little bit more about this, but the question was, how do you kind of start coming up with ideas and strategies on how you think you're going to win the game?
So this year's game was really similar to what it was in 2020. So we basically looked at what we did in the past and was like, okay, how can we make it work for this year? So we started out with our drive base, and then we kind of had a similar shooter design. And then we also looked at how could we make the intake more effective and less likely to get jammed up. And we came up with this. It's a really large process, but I think we did pretty good.
Yep. Another question?
We have a couple of things. Also, only in Antarctica reminded us that they live in Toronto, not Antarctica. Canada, that is. Bob says, awesome robot, well done. One question here from Astronomy Web is, does the robot have a name?
So we came up with it during competition because it's called Carpet Crusher, because during the competition we got stuck on part of the field, and the field referee ran over to us because our wheels are so traction limited that we actually burned a hole through the carpet. Yeah, if you get stalled or stuck on something, you'll burn through the carpet in 2 seconds. Yeah, so usually we have a cooler name, but we didn't come up with a good name until competition.
All right. Bob asks, why lead acid and not lithium ion or lithium lipo? Yeah.
So that's just the rules of the robot. In the game manual, you have to use a specific model battery, and I'm pretty sure the reason is I don't want to put words into First's mouth, but lipos require a lot more safety precautions where if you over discharge it or overcharge it, they actually explode instead of just leaking. The worst thing that can happen to a lead acid battery is a leak, but it's not as dangerous as lipo batteries. And yeah.
Another question from Linda. How much consideration is given to style or looks?
Yeah, so there actually is an imagery award that's given out sometimes, or I think there's also another one. I don't remember the name, but yeah, there's definitely taken into consideration when the judges are giving out those kinds of awards. Some robots end up like painted in their team's colors or that kind of thing. Like I know there's a team in Pittsburgh called Girls of Steel who all of their team members dress up like Rosie the Riveter, and their robot always is like painted and looks cool. So yeah, it's definitely yeah, there's just an award for that. So
Any other questions here?
Andy, where are you going to school next year?
Oh, I am going to go to SUNY Broome for 2 years.
What were your ultimate major?
I got in for engineering science, but I haven't picked my classes yet. So.
Electrical, mechanical, civil.
Yeah, the first 2 years are always.
Right, but you have some idea which way you're going to go.
I'm thinking about mechanical.
Is there any tension between doing your homework and building your robot in terms of your personal time budget?
Not as much. I think this year I kind of got off easy because a lot of my teachers gave more in-class work than homework. But no, I don't really think so. But it's different for everybody.
Yeah, the question was, is it hard to balance your work and club life? And at least for me, when I was on the team, it definitely was. I know when I was in high school, I was kind of crazy and didn't really focus on schoolwork as much as I could. I was basically the only programmer on the team when I was there, and I mean the meetings normally are every day from 4 to 8 p.m. Except Sunday, and so I was there every day, and I did end up putting off schoolwork, which isn't a good idea, but I definitely learned a lot.
Have you given any thought to getting a teaching degree?
So the question was, am I planning on getting a teaching degree? And my answer is probably not, just because I work at Lockheed Martin, and the pay is a lot better for that, and I kind of get my teaching I have a really fun time mentoring the team. I don't plan on quitting or giving up anytime soon. I think each year I learn as a mentor too on how to teach kids better, and also from a competitive standpoint, I think it's also important to have someone that's been there for a long time that knows previous games and strategy and the meta game. So it's also important. Yep.
So besides more students to participate, what does Southern Tier Robotics need from the community or the school would be more successful?
Yeah, so the question was, what is a community do we need from you guys? So Vestal School itself has recently given us a large grant which will allow us to purchase machines that we had at Union Endicott schools, which include a CNC mill, a CNC lathe, a CNC router. So we'll be able to prototype our parts a lot faster and do stuff in-house more. But as a community, I guess, obviously more students, more mentors would be good. Having 3 mentors, it's kind of hard to do more than, 20 students, I'd say, just because you want to have each student, actually have valuable mentor time. I think that's important. And then also, we're planning on trying to do more fundraising from local companies to try and go to 2 competitions next year. Our goal is around, at least just to go to the competitions, is probably around 30 to 40K, because each competition is $6,000, and then travel costs is what makes it a lot expensive. So, because each competition is 3 nights in a hotel. So lots to do. Yep. Yeah, so the question was, do companies give us parts to use during competition? So some of the parts, like motor controllers, you need to use certain approved motors and stuff like that. But specific parts, it depends on the company. Like a lot of the stuff you get in the kit of parts each year includes random company-sponsored parts directly from First. So the foam rollers we use to pick up the balls inside the robot were in the kit of parts. Kind of just, I think a company would probably be better offering, their services or direct monetary funds, if I'm being honest. But any part could be, a good part. Like, I know with weird shaped game pieces, you might need something specialized that a company might, donate or something. Yeah.
All right. I don't see any other questions on the live stream. And Jeremy, you're saying the clouds are sort of in and out? All right. Well, the rule here is, especially if this is your first time at Kopernik, you cannot leave until you look through a telescope. We'll track you down. But anyway, Drew, Andy, and Nathan and Jalen, thank you very much for coming out and presenting to us here. And I'm wondering if I could get maybe a picture of the robot and you guys in front of our Perseverance.
Can you shoot a couple more balls for a video opportunity?
Yeah, sure.
All right, I guess we'll shoot some more balls. And, all right.
When the computer turned on,
You ran my toe over.
I'm literally
Let me take a little moment
not my fault.
to get it reconnected up to the
Where's the
laptop.
balls at? Oh, they're over there.
Maybe not. I think the laptop might have died.
Oh.
So unfortunate. I didn't know the battery was low. But yeah, you're free to come take a look up close at the robot if you want. I'll turn it off, so we'll attack anyone.
No shooting?
No, it's the laptop died, so we can't control it.
Yeah. All right. Well, thanks again. And oh yeah. Well, yeah. When they go to move it, yeah.
Yeah. So I think about it now.